How are you, everybody who is watching this video? I'm very happy to have you today. Okay, my name is Olenjolai You're single. Simply call me Sir Olenjolai. I'm from Tanzania, eastern of the African continent. I'm very happy to have you. Whether you're international or a national viewer, I'm very happy to have you, and I would like to welcome you into this fantastic moment of receiving good news from the special online channel that is called the Online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, and also with the combinations with Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. So I would like to take this opportunity to welcome you into one of our online schools that's called Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. And simultaneously, we'd like to welcome you into another one of our online institution, which is called the Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. So this is wonderful enough because the combinations of an institutions with the advanced secondary school, because we are in this session or in this lecture, we are going to cover the same contents that have to be covered in ordinary diploma, and also the same concepts have to be covered in advanced secondary education. So that's the good news. We have our YouTube channels. Make sure that you read the introductions part of this video so that you get so many informations concerning about how you can access our content. So the next question, after you've been welcomed anywhere else, you get in. So you are inside Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. Simultaneously, you are inside Online Diploma Polytechnic Institute of Tanzania in square bracket OLENJOLAI. So the next question, what is your visions? Because the book of Proverbs 29 verse 18 say that where there is no vision, people perish. So if we don't have visions, we are going to perish. We who are teaching, and even our students also will be learning through our own platform. So the answer of that question is this one. We have an assignment to teach, to train, to incubate by using different teaching methodology and different teaching aids our students on how they can extract knowledge from the formal and the informal classroom education to combine with the knowledge of the Word of God that treats in the Holy Bible in order to solve real life problems. So that is an assignment we have. It's a long-time assignment that we have, but we believe as time goes, we are going to develop and build in the mind of Tanzanian students and even African students and even international students. So we have some of the departments in these online institutions and also online advanced secondary school. One of the departments is called the Departments of Advanced Mathematics, where we are teaching a subject, 4 subjects, Advanced Mathematics Form 5 and Advanced Mathematics Form 6. And then we are teaching Basic Applied Mathematics Form 5 and Basic Applied Mathematics Form 6. Again, we have another department in Online Diploma Polytechnic Institute of Tanzania, square bracket OLENJOLAI, that's called Basic Departments of Basic Engineering and Scientific Mathematics, where we are teaching 6 modules, and one of the module is called which we are discussing and I'm teaching you today, is called the connexity and the differential equation. So the subject of the day, in Departments of Advanced Mathematics, we have a subject called Advanced Mathematics Form 5, and just the classes for the Form 5, and then Form 6, excuse me, classes for the Form 6. The topic is called the coordinate geometry 2, right? So this is it's chapter 1. So it's the first chapter in Form 6 education. It's called coordinate geometry 2. But in online diploma or in departments of basic engineering and scientific mathematics, this module is called the connexity. The ordinary diploma, what actually the ordinary diploma students used to cover in connexity, it's a subset of what advanced students used to cover. However, that in some of the parts where there is a synonyms of the contents, because I know the curriculum of ordinary diploma third year students, especially for the part of the connexes. So I know what they have to cover. And also I know the curriculums and the syllabus of advanced mathematics Form 6, especially in the part of the coordinate geometry. So I'll be recording one session or one lecture when they share the same, or they have to cover the same contents. So in case that they have to cover different contents, so from there I will teach the ordinary diploma third year students themselves, and I will teach the advanced secondary students themselves about the coordinate geometry too. But in case of the synonyms, we have to I'll be maximizing the time on recording the single session or single lecture, just like today. So we are in the second subtopic. The first subtopic ordinary diploma and even advanced secondary students, they have to cover about the conic section, which we have covered already. And this second subtopic is called the parabola, saying the parabola. So the parabola is the second conic section. The first one is called the cycle, and the second one is the parabola. The third one is called what? Ellipse, and the fourth one is called the hyperbola. Okay? So I believe that you've understood. This is lecture 2 in case of the sequence of the lectures for ordinary diploma. But this is session 3 in case for the advanced secondary students. And today I'm going to teach about the standard equation of the parabola. That's the message that has been written in my heart, and I want to take you into the next step right now. These contents for the advanced secondary students have to be covered during by the pre-Form 6 or Form 6 students in the 4 combination PCM, PGM, EGM, and even PMC. And the year of the study for ordinary diploma, these contents is covered in the first semester in the third year of ordinary diploma, because we have an assignment to prepare competence-based ordinary diploma student. So I have been giving you so many instructions. Before even I go further, or just take you into today's good news, I would like just to remind you that quickly in both departments, in both online institutions, online schools, online learning institutions, or learning schools, we have online library. So there's a library, we call it online library for Tanzania Online Advanced Secondary School, where we have some tools or some books, some textbooks, some questions and answer books, some materials, some devices, and some materials which help our students to learn and master the subject without any kinds of too much hassle. The first weapon is the syllabus. Really, we recommend all our students to have a copy, either the original of this book or a copy of this book, which is called the Advanced Mathematics Syllabus for Advanced Secondary Education from 5 through Form 6. So you can order this book or you can order a copy of it. Just go to the descriptions below. You will see you can order in any regions of Tanzania, and then we try our level best to ship it to you. Again, we have Pure Mathematics 1. So this is the one of the textbook. This is the second weapon. So we have Pure Mathematics 1, and then this is by J.K. Backhouse, and also we have Pure Mathematics 2 by the same authors. So we have in our library, you can order. We are just providing service. We are not doing business. We are selling these books with a cheap, very cheap price, but also in case you are living out of Dar es Salaam, then you have also to pay the shipping costs, so you can ship in any regions within the 31 regions of Tanzania. Again, another weapon is Advanced Mathematics. You have a book, this is the question and answer book called the Advanced Mathematics 1. It comprises problems and solutions of 2003 through 2018. I'll be using this book. You can order it. We have so many books of Advanced Mathematics 1 review in our library store. So you can order it and then we can ship to you. Another first weapons is Advanced Mathematics 2 review. So this also is a very nice book. You can order it we have in our store. You can order it online and pay the shipping cost, and we advise you as the parent or guardian, you can order the package of this book, because you will minimize your shipping cost. You'll be just paying your shipping cost once, and your students is well equipped with valuable materials which have been recommended by the syllabus of United Republic of Tanzania. If you're an international student, don't be disappointed also. International contents and international text books and questions and answers books and materials are still on process. So soon we are going to inform you on how you can access them in any country, because we want to cross the borders and help millions of the students in African continents and even other countries. So this now is another material which is very important for all, for both the Online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, and also in Tanzania Online Advanced Secondary School, in square bracket Olenjolaim. So this certificate calculator is very important. We are selling, we have different types, but really we recommend Casio function 991 for your students, or for you as the students. You can use it and it can last it for a long time, more than 3 years. We have original scientific calculator. We are just selling with a very reasonable price. It is cheap, just minimum price, and compared to the local price, and they are original scientific calculators, because we have a mechanisms of testing whether it's original or it's not original. So that's all about what we have. We like to share with you in advance before we take you from one point to another point now. So let us now, I believe you're serious students, you have your exercise book, you have your reference books, and then you have your scientific calculator, you have your fresh mind, you are ready now to go into the live class. So let us go to the live class. Okay, so let me begin on the quick review of lecture 1 in case of the conics, and also this was session 2 in case of 40, in case of coordinate geometry 2. Basically, what I've taught you there, I've told first of all, I have mentioned how we can cut the cone and get circle, how we can cut also the cones and get parabola, that we are going to start today, how you can cut the cone and then we get the hyperbola, and how we can cut the cone and get ellipse. But near the end of that session, or that lecture 1 or session 2, then I told you about terminologies. Terminologies of what? Terminologies of coordinate geometry 2 that you are going to use in coordinate geometry 2. So I mentioned so many terminologies. Some of the terminologies I mentioned about focus, I mentioned about the electrics that we are going to use from today. I mentioned about foci, okay, foci, that's a focus. I mentioned about eccentricity, which is eccentricity. I mentioned about latus rectum, okay. Then I introduced to you about the center. I introduced to you about axis. Then I introduced to you about the vertices or vertex, etc., etc., etc. So in case you missed it, we still have most of this. We still have lecture 1 in online in one of our YouTube channels that are providing essential contents for learning in Online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, which is called the Online Diploma Poly Institute of Tanzania in square bracket Olenjolai. So you can just search in the YouTube search engine. Again, so you can access all of these contents in session 2 as titled as session 2, which has been the concept, which has been titled as the concept of conic section. The concepts of conic section. So let us go to the today. So today we have a subject, a subtopic that we call the parabola. So just write on top of your paper the word the parabola. Say the parabola. In many cases, I know that this might be your first time to hear this word, the word parabola. However, that we are always watching different stations on the TV by using different antennas, right? We call this different antennas or access of the satellites. And you have a dish antenna at your homes, but you've never bothered. But that's not the case. We use actually to make, well, once that in Tanzania or in many of the African countries, once we want to cook for the rice, during the preparations of the rice before actually that we take it and put into the boiling water and cooking oil and other essential materials or requirements, then what happens that we can separate the particles of the rice with other unrequired particles by using a kind of the interesting plate, which is in the form of the parabola. Interesting. So the word parabola is not new to you. The structure of the parabolic or parabolic structures that you are talking is not new, because you see the dish antenna. Even if that you don't have a TV or a dish antenna to your home, but you see in the street, in the tall buildings, you find that antennas. You see in the, for example, that in the transmission stations, or it is a cellular transmission station called base station. So you see dishes are dish antennas. Okay. So the fundamental question that we have is, what is parabola? So what is parabola? That's the fundamental question that we have. So we say that parabola in the conic section, parabola is a conic section which its distance, or which, okay, in which it's a, okay, in the conic section in which the point, we call it the locus of the point. Should have your exercise book, should have your pen, should have your ruler, and you have to get ready to receive the good news. Receive the good news. So it's the locus of the point. So we say that parabola is a conic section, first of all, so you know that, in which is a conic section. Okay? Parabola is a conic section. Okay. That's not a new sentence for you. Let's go to the interesting point. Parabola is a locus of point. Parabola is a locus of point which moves such that its distance from fixed point, which we call the focus, is always equal to its distance from what? From fixed line, which we call the directrix. So this is the definition of parabola. So parabola, what's the parabola? Is a locus. Say locus. Locus of what? Of point. Which that's what? Moves in such a way that its distance from where? From the focus is always equal. Equal to what? To its distance from where? From the rectix. So according to some specific objective that has been laid out by the Tanzania Institute of Education, then we have to teach you how you can derive the equation of the parabola. And that equation of the parabola, we call the standard equation of the parabola. And in the next session or next lecture, I'm going to teach you about how you can derive the equation of the translated parabola. It means that the parabola whose vertex is not at the center. Okay? So this is the definition. But the second specific objective, we have to teach you how you can draw the graph of parabola. So to understand this definition, let me just take you into the next part of specific objective of today, that graph of 40 of parabola. How can we draw the parabola in XY plane? Well, so first of all, we have to draw our XY plane. In our XY plane, we have 4 quadrants. Okay? So we are not going to focus into all of these 4 quadrants, but we are going to focus so this is the x-axis, and this is y-axis, and this is the x-axis. So this we used to call in mathematics the first quadrant, and this the second quadrant, and this the third quadrant, and this the fourth quadrant. So actually, a parabola should be within either in one quadrant or in two quadrants. So let us start with the standard parabola. So the standard parabola is the parabola whose is the curve, whose vertex is at origin and lies along the positive x-axis. So remember that this is called the positive x-axis. Here we have negative x-axis. Here you have positive y-axis. And here we have negative y-axis. Okay? So if this is the case, we say that, remember that I told you that in every aspect, say that suppose that this is 10 and this is, let's say, 5. So here we have a focus. So then say that, okay, it should come up to here. So here we are going to have a fixed line. Do you remember how we call this fixed line? This fixed line in mathematics we call it directrix. So you have to listen carefully. Directrix. So this is the graph of directrix. So then this is the focus. Okay? So here we have focus. This we call the focus. And this is the parabola. We're going to derive this question soon. And this is vertex. So this is the point that we call the vertex parabola. And this is the endpoint. Suppose that this is point P, which is x, y. So the distance from what? From the focus to the point is this. And then this again, here we have another point, which we call the M. Okay? So in this one we call it directrix. Say directrix. Directrix. Okay? Directrix line. So this is figure 3.1. Okay, so that's the directrix line. So this is the directrix line. And then this the parabola itself. Can be lines along the positive x-axis, can be lines along the negative x-axis. A parabola can be lying along the positive y-axis. A parabola can be lying along the negative y-axis. Okay? So you have to pay attention when you're learning about the parabola. So that's the figure of the parabola, and this is the structure of the general structure of the parabola that we are going to discuss. So you see the focus, you see the directrix, you see the vertex. This is the point, we call it point P. So according to the definition, we used to say that the distance, so suppose that this is S. So according to this definition, we say that it's the locus of the point which moves in such a way that is distance from the focus. So distance, so this is the point on the parabola. So it's distance from the focus, so we call it the PS. Is always equal to its distance from what? From the fixed line, which we call the PM. So the distance from P to S is equal to distance from P to M. That's the unique property of a parabola. And that property distinguishes a parabola from a circle. That property distinguishes a parabola from ellipse. And that property distinguishes a parabola from hyperbola. What point? The distance from this point, from the point, any points along the parabola to the fixed point, which is focus, is always the same to the distance from that point to the fixed line, which we call the directrix. Remember again, vertex is the center of 40, is the center of the distance between focus and the directrix. Okay? In case you have any question, don't hesitate to ask in the comment section here. Comment section is for you and the students to interact with me. Okay, don't assume that you've understood everything. some of the materials I used to provide once the students has asked their question. So even myself, 80% of what I'm teaching you, I learned them informal. I didn't learn them from school. I learned them myself. Okay. So, and I learned them by asking myself so many questions. So then now, let us go to the next part, which is the derivations of the standard equation of the parabola. So we say that let us go to the next part, the derivation of the standard equation of parabola. So because the standard parabola can lie in 4 possible regions of XY plane. The first possible regions, it can lie along the positive x-axis. Or this parabola, it can lie along the negative x-axis. Or this parabola, it can lie along the positive y-axis. And this parabola, it can lie along the negative y-axis. Right? So we are going to have 4 different formulas. I'll derive 3. 1 is your homework, because I love you to try during the practice and during the learning period. So once you go in exams, every question will be a repetition for you. So let us begin with part A. We say that if the standard parabola, STD, the standard parabola lies along what? Lies along x positive x-axis. Positive x-axis. Lies along positive x-axis. Okay, so what do you say about this? If the standard parabola lies along the positive x-axis, so you are going to follow some steps. So the first step, we say that consider a parabola in figure 3.2 below. Okay, so let us consider a parabola 3.2 below. So now I'm going to sketch a figure 3.2, which is a detailed parabola. It is a detailed parabola. Okay. So this is y-axis. Next we have the x-axis. Have the x-axis. It is bent. Let me try my level best to draw a straight line across this line. Hopefully. So this is 0,0. This is y-axis. And here it is x-axis. So we have y-axis and then we have x-axis. Okay, so we say that we have this parabola, which is y-axis, and then we have x-axis. Okay, so here we have a parabola. So this is our parabola, as I said. Then let us have a distance. Distance of what? 10. 10 to 4. So this is 1, 2, 3, 4, 5, 6. 1, 4, 1, 2, 3, 4, 5, 6. So here we are going to have our dialectics. So this is our fixed line. Okay, so you have to listen carefully. Fixed line. And this is figure 3.2. Okay. So again, this is the focus. You can find that possibly this line is a little bit, it's not perpendicular to the surface. So this is the focus, we call it S, and this focus usual for this standard parabola, we have a point which is A, 0. This A is a known. And then we have a certain point here, and this is the end point. So it is P, which is X, Y. Then we say that, if you do remember that, in figure 3.1, we have a distance, and this point is called the M. So this point M, it's what, because remember the distance from here to the vertex, this is the vertex V. The distance from focus to the vertex is equal to the distance from vertex to the dialectics. So if the distance from here to here it is A, here, so even this one it is A, but in the opposite side. So that's why the equation of dialectics is equal to negative A. So this point, it is A, it is negative A, 1. Negative A, 1. So that's a point M. So coordinates of point M. So then here we need to join these 2 points, point P and point S. Okay, so we have 2 points. So point P and point S. So this is negative A. Comma 1. 10, comma 1. So this is 20p, which is x, comma y. X, comma 1. Okay, so you have point S. This is the distance from here to here. And this is the distance from here to here. Okay, so this is our figure. Now, we as mathematicians, we can do great things now. Once we have that, we can do great things. Remember that I told you in the previous session, which is session 3, session 2, and previous lecture, which was lecture 1, that the simplicity of the ellipse, the simplicity of the parabola is 1. So the second step, we say, what is parabola? Parabola is a locus of the point moves in such a way that its distance from the fixed point is always equal to its distance from the fixed line. So the second step, we say that we call the formula for what? For eccentricity. So you say the eccentricity is equal to what? Is equal to SP over PM, or vice versa is true. Okay? So we say that, but I told you simplicity of parabola is 1. Right? So centricity is equal to 1 for what? For any parabola. So if that is the case, so we say 1 is equal to, suppose that this is equation 1. So 1 is equal to SP of what? PM. So if we multiply by PM, both sides, then that's why we end up with PM. Okay, distance PM is equal to SP. Okay, so now in terms of the distance, right? We want to find the distance, right? The distance, which you call T sometimes magnitude or whatever. So we say that the distance of PM, this is equal to what? Square root of what? So for the PM, distance from this point to this point. So we say that this is equal to XC. So suppose that this is equation 2. So you have XC minus negative A, which is XC plus A squared, plus what? Y minus Y squared. So the distance PM, this is equal to what? Square root of what? Of X plus A squared plus D squared. Okay? So it means simply the distance from P to M, this is equal to square root of what? Of XC plus A squared, and this will make the steady equation. Wonderful. I believe you're enjoying the beauty of conics, and especially the beauty of parabola. Okay, so this is still a fundamental concept of parabola. We didn't get into advanced concepts of parabola. So then we say that we have what we have again distance SP. Okay, distance SP, we want to find the distance from P to S. It is XC minus A. So it is XC minus A squared plus, then we have Y minus 0. So it's Y minus 0, then we square. So then the distance SP, this is equal to square root of what? X minus A squared plus Y squared. This will make equation 4. So you have equation 4, you have equation 3. Let's substitute in equation 2. That will be the third step. Okay? Enjoy the beauty of advanced mathematics. Third step, we say that substitute equation 3 and the equation 4 into equation 2. So to substitute it, we say that we have a square root of XC plus A square. This is equal to square root of what? Of XC minus A square plus Y square. Then we square to both sides. Okay, so once we square to both sides, we get X plus A square. This is equal to what? X minus A square plus Y square. So we go to the fourth step, right? The fourth step, this will make equation 5. Right? This will make equation 5. We say that expand terms in equation 5. So expand terms in equation 5. Ladies and gentlemen, welcome to enjoy the beauty of parabola at the concept of the conic section. Right? So then if you expand on the left hand side, we'll have X plus A times what? X plus A. This is equal to what? This is equal to XC minus A times XC minus A plus Y square. So X times X, this will make X square. X times A, this will make AX. A times X will make AX. A times A will make A square. This X times X is equal to X square. X times A, this will make A X. Then negative A times X, this will make negative AX. And then so we say that negative A times negative A, this will make A square plus Y square. So then we collect the terms. So to collect the terms, we have X square minus X square because they are same. Then AX plus AX make 2AX. And then so on this side, negative AX minus